Good day, everyone. My name is Romain Bailey. I am an undergrad student at Oklahoma State University. I am currently studying aerospace and mechanical engineer. Today, I will be talking about the effect of diurnal cycle in the atmosphere boundary layer on mantle aerial system. This study is to provide better understanding of the physical processes and provide better data for numerical weather prediction models, reducing the level of uncertainty and the need for simulation. Furthermore, these technologies still need more development. The atmospheric boundary layer is the layer where the atmosphere is directly influenced by the surface of the Earth. The two main factors that influence the atmospheric boundary layer is thermal effect and surfacing force. Thermal effect is the surface heating by the sun, and surface forcing is the friction and the heat flux. Diurnal cycle. It has two: nighttime, which is considered as a stable boundary layer; daytime, which is considered as a convective boundary layer. To further explain the diurnal cycle, when the sun rises in the morning, the heat heats the Earth's surface and start driving a convection and mixing boundary layer. As the sun increases throughout the day, you have more energy and can rise the boundary layer. The boundary layer is where the part of the atmosphere directly affected the Earth's surface. Temperature is not the only effect of the atmospheric boundary. The atmospheric boundary layer experiences effects from the wind over the Earth's surface. The thermal effect by the clouds is also a factor, the moisture in the air, as well as pollutant of the atmosphere. All these factors play a significant effort of influencing the weather. The strength of the turbulent mixing is extremely valuable and key to our understanding the aspect of the boundary layer so we can further predict the weather. Unmanned aircraft system. These provide high-quality atmospheric measurement for meteorology study, capable of providing information of temperature, moisture, and wind within the atmospheric boundary layer, and helps to determine the weather development. The primary goal is to operate in variety of weather conditions, including day or night operation. To further explain, unmanned aircraft systems were designed to understand severe storm formation. The importance of having a better development sensor or communication system for the unmanned aerial system gives us accurate data for atmospheric boundary layer to predict severe weather such as hurricane, tornado. Having these sensors gives us measurement of temperature, pressure, humidity, and wind speed. We can design different aircraft for different missions to achieve this ultimate goal of understanding the atmospheric boundary layer. In this research, the large eddy simulation is used to understand this model. The large eddy simulation can be applied to a two-dimensional or three-dimensional flow. Finally, the large eddy simulation that was used with CM1 coding. To further understand stable boundary layer prevail at night and can also prevail during daytime in winter time in polar region. One importance of atmospheric boundary layer is the turbulent nature of flow. In a turbulent flow, large eddy simulation of different scale is used to analyze flow. In stable boundary layer, the temperature increase with height in development can overestimate in temperature for calm night can cause error in our data. Layer depth is usually deep to obtain accurate forecasts from atmospheric model. These issues occur typically under a very stable condition. So understanding and predicting of stable boundary layer is a challenging task. Stable boundary layers suffer from variety such as temperature, 2 meters and below, boundary layer depth, and boundary wind speed. This makes it so difficult to predict. In setting up the condition for our stable boundary layer, these are the domains we use. You can see that the boundary layer is almost stabilized as it reaches its maximum height. Same as the v velocity in the z direction. And the double velocity in the z direction. Convective boundary layer. We neglect roughness under the fair weather condition during daytime. At sunrise, the heat from the sun causes convective boundary layer. This creates weather patterns that can be used in numerical weather prediction models. The solar radiation is absorbed by the Earth's surface, then immediately heat up the surface. The qualities that affects the convective boundary layer are the heat flux and the thickness of the convective layer. As time passes, the growing convective region eventually reaches a high as it did on the previous day if condition does not changes. However, a thick layer of clouds can intercept much of the sunlight and reduce the amount of heat that reaches the surface. Furthermore, convective boundary layer also depend on wind velocity as well as roughness of the surface. In summary, atmospheric boundary layer is generally convective during daytime when the sun rises and heats the ground surface. The convective boundary layer setup was similar to the stable boundary layer. As you can see on the graph, as the sun starts to heat up the Earth's surface, we began to having a convective boundary layer. In conclusion, atmospheric boundary layer is generally convective during daytime, when the sun rises and heats the ground surface. When convective starts to occur, the height is usually around 1 to 2 kilometers. This creates weather patterns that can be used in numerical weather prediction models. However, as the sun sets, the solar heating of the surface and the convection are starting to end. This creates a stable boundary layer during nighttime. So having a better sensor on an unmanned aircraft system can provide better understanding and better data for numerical weather prediction models. Can